environment, which is the part of environmental monitoring. So both the subsections 3.1 and 3.2 is related to the environment monitoring and conservation policies using remote sensing techniques. When we say the remote sensing means we are talking the satellite data. And as we know, the satellite data is available, especially from 1972 up to now, ongoing satellite programs, continuous, going on. So these satellites programs are giving us very useful data. The data which we can use to monitor land use, land cover, as well as we can do analysis, we can do climatic analysis also. So these are the two subsection under chapter 3, 3.1 land use and land cover, and 3.2 is the climate. So let's take one by one. First, we will discuss land use and land cover. So let's move to chapter 3. Land use and land cover. First, what is land use and land cover? There are two ideas. One is land use, another is land cover. Land use describes how land is utilized for specific human activities, such as residential, whether it is residential, commercial, agriculture, industrial, or recreational purposes. On the other hand, land cover is a journal. I mean, how the land is covered, either by natural or artificial features, such as forest area, water bodies, urban areas. Of course, urban areas are not natural. These are man-made, but it will come under land cover. The land is covered by urban areas. Cropland area is also not natural, but it's man-made. So land cover means the cover at the surface of the earth, whether this is natural or artificial. While land use is more focused to how the land is being used by the human beings. So this is the idea. So as a whole, we can say land use and land cover. So this is one uh, aspect which we can say land use and land cover. So the land use, what are the classes of land use and land cover? These classes here, around 14 classes are given, but these classes may be more than 14 or less than 14 in any specific area or in any specific region. For instance, here glaciers are given. It's not necessary that glaciers will be found everywhere. No, maybe if we are studying the polar areas, there are some temperate regions, there glaciers may be there, or high mountain areas, maybe glaciers there, but glaciers are not found in Nigeria. So these classes may be more than 14 or less than 14 also. It depends on the classification scheme. But the general classes given here, urban areas, the areas, the class which include cities, town, or developed areas, the uh, the basic characteristics is that these are the high density areas where density is more, density of buildings, roads, and infrastructure is more in urban areas. And then agriculture, land, agriculture, the culture here. This is the culture of interacting with maybe the land, soil, water, minerals. Uh, I mean, uh, yeah, these are I mean, agriculture includes the farming, the cropland, orchards, vineyards, or other cultivated areas. Forest and woodland. So forest and woodland landscapes are there where the density of trees are more, and these can be, I mean, these can be further divided or categorized based on the characteristics of the trees. Then the grassland, where the grasses is there. Water bodies, I mean river, lakes, reservoirs, wetland areas where the high water tables are there, flooded areas, swampy areas, marshes, bare soil, snow, maybe built up areas, then crop, then shrubland where the woody vegetation is there, water bodies inland, coastal area, and glaciers. So it's easy to read and to understand. There is no problem. There should not be any problem to memorize all these 14 classes and to explain. And this will be the, I mean, you may be having in your mind that what will be the question in the examination. So the questions will be from these topics only, which I think will not be difficult to explain. What is land use, land cover, and how it plays its role in conservation policies. Here, what I want to, yeah, after this, after conservation policies, I will demonstrate something with the help of some platforms that how land use and cover can be understood, or can be, we can do some analysis related to land use and land cover. So there are some conservation policies which are related to land use and land cover. What policies are there? The policies like how the land use planning should be done. Okay, I mean, especially the urban areas are divided into different zones, and these zones belongs to residential, commercial, or industrial area. And the objective is to optimum use of the land and how we can conserve the uh, the natural habitat or the natural areas which should be conserved, like water bodies, forest areas, or some wetland areas. So this is what land use and land cover uh, should be understood. Then under land use and land cover, there are protected areas and reserves. These protected areas and reserves are protected to protect some I mean, to protect some wildlife or some kind of plant biodiversity. So the protected areas are in the form of national parks, wildlife reserve, marine protected areas, etc. Habitat restoration. Habitat restoration involved identification of degraded ecosystem and how that degraded ecosystem can be restored. So it includes the reforestation, wetland restoration, or some kind of invasive species removal. Land conservation easements, how we can conserve the land. I mean, this with the help of policies which landowners and conservation organization or the governments make some agreement. Okay, this is the limit. You can do this or you cannot do this. Smart growth and compact development. The smart growth is in any land use land cover, how the smart growth can be achieved. Agriculture conservation programs, and then forest management. Okay, the wetland and riparian area protection. The riparian area where the drainage, the rivers, channels are there. So the channels should be protected for easy flow of water. Then urban green spaces and parks. And then land use impact assessment, and then climate change adaptation. So this is all about land use and land cover. The next part here given is land use and land classes data analysis. Now we are coming to the remote sensing. As we have already understood, in remote sensing, we collect the information of the surface of the earth using the reflectance using the satellites. So the satellite gives us the images in the form of bands, and these bands helps us to classify the surface of the earth into different land use and land classes. So why this Google Earth Engine is mentioned here? Because Google Earth Engine has emerged as a most popular platform to collect the remote sensing data. Not only to collect the remote sensing data, but also to do some analysis also. So here, this is the Google Earth Engine platform. And this platform is how we can do analysis at any part of the earth. Now the question is, what type of data Google Earth Engine is giving us? We can click here, user guide, and we can see the data catalog. So this is the catalog of data. There are different types of data, almost if we see all data sets, then Earth Engine is giving us a wide range of data. This data, I mean, there are different types of data. There are few data sets which are important for one place, or maybe for at global level. So you have to look at that what is your objective to study. Based on your objective, you can choose the best data to meet your objectives. That's why I introduced you to this platform, that is Google Earth Engine. So I will advise you, you please visit this link here. I will share this link. I will share this link with you, and if you are interested, you can explore more. And it's uh, I mean, a small practice can make you understand about this. For instance, this is here land use and land cover. So when you will click this one, you will go, I mean, you will enter into this data set, and then they give some examples here, and then you just click here, open in code editor. Then you can run it. Then you can see the land use and land cover of that area. So this is the way we can access the land use and land cover data. But of course, this is uh, something which needs some prior knowledge or some extensive practice. Before that, you can open this platform also. Here, there is no coding required. Simply, you can open the platform like this, and then yeah, you can click here, land cover. So this is the land cover data you can look at. Here, this is Abuja 2024. You can slide to back 2017. Abuja was like this. So how much area in 2018, 2019, then 2020, 2021, 2022, then 2023, then 2024. So you can look at this bottom right side where the area, how much crop area is 31. This is built up area, this is bare area, and this is rangeland area. You have to click at any point. Wherever you will click, it will give you the information. Okay, you can download also in the form of GeoTIFF. So this is easier to do some analysis or to for visual interpretation. This is a good platform when we if we are interested in land use and land cover. So now I'm coming to the remote sensing part. The remote sensing, here the subsections are Landsat images, Sentinel-2 images, MODIS images. Here this is National Land Cover Database. And there are some another platforms. These platforms can help us for land use and land cover data analysis. There is a difference. Landsat images are available since 1972. I mean, better from 1985, even more better from 1991. And then as we are moving onward, the quality of the images is getting better. When I say quality, here the quality in the quality, I mean, in terms of the spatial resolution as well as the radiometric resolution. The quality is getting better. So Landsat 5, Landsat 7, Landsat 8, and now Landsat 9 is also there. So we can use the Landsat images for land use and land cover mapping. Here the spatial resolution is 30 meter. But if we are working with Sentinel images, here the resolution is 10 meter, 20 meter, or maybe 60 meter also. The revisit time here 16 days, here 5 days. So using these satellite programs, uh, we can do land use land cover classification or mapping. Also, MODIS is the resolution is 250 meter to 1 kilometer. So these are the important three programs which are being used for land use and land cover mapping. All right. So here this platform is Sentinel-2. So as you can see here, Sentinel-2 is 10 meter. So they are using here 10 meter. So this pixel size is 10 meter here. When you will zoom in, the pixel size, I mean this pixel size here is 10 meter by 10 meter. So this image will give you better resolution, better spatial resolution. If you are doing land use and land cover mapping with Landsat data, resolution is 30 meter, which is not as good as in the Sentinel-2 images. Why as not good? Because here the resolution is 10 meter, here resolution is 30 meter. So here Sentinel-2 is better than Landsat. But as we see, the Landsat program is running from 1972, but Sentinel program is running from 2017, I think. Yes. So if we need to study what was the land use land cover in 1990 Sentinel data, we cannot use. We have to use Landsat data. Okay. So here, this is how we can do some land use land cover analysis using different satellite programs. So here this is, if you will see this course web page using your laptop, you can access land use land cover here also. And here I think when you will click, a pop-up will be there. Okay. So this is about land use land cover. We move to, yeah, here. Okay. Okay, I think there is some Mr. Search Okay. Is there any
Yes,
question, please?
yes. Just to know if this page is your personal page or is accessible on Google Engine, Google Earth Engine, or is it your personal link that you are showing to us?
Yes, yes. Actually, this web page, from here we cannot go to the Google Earth Engine. Here, this is the application which I developed using ArcGIS Online. This application, Landuse Landcover 2017 to 2022. So this is not linked to Google Earth Engine, but the second one, which is NDVI time series analysis, this application I developed using Google Earth Engine here. So NDVI means normalized difference of vegetation index. If you will click at any place here, the Nigeria site, then of that area where you click, you can find the time series of NDVI. Now I'm coming to your question. Your question is that how we can mm, go to Google Earth Engine and how we can collect the data or we can do some analysis. Uh, am I right, Mr. Search? Am I right? I mean, you need to know how
Right.
we can do with Google Earth Engine. Is this your point here?
Yes. My question is how you were able to generate this
The
page,
applic-
this web link.
okay, okay. How we can generate these web maps, right? Like this?
Yes, exactly.
Okay. So
Yes.
yeah, when we have the Google Earth Engine, uh, when you are working with Google Earth Engine like this, and then if you have some code let me show you one of my code here that is some kind of mm, like NDVI, maybe like this, maybe. Yeah. So this is the NDVI. And now if uh, I want to develop a application which shows this NDVI, this vegetation, then I will go to the apps. Then I can go to new app here, and then I will go to next here. You can read all these points. Next, and then I will go to next. Next, they will ask source code. What is the source code for your web app? Then when you will click next, then okay, source code. Okay, here you have to give some name like the name. Then you will click the next. Then here you can choose current content of the editor. The current content of the editor is the current means this one, this content. So this content will come to your application. You will click the next, and then your data, this data will be used in that application, and then they will generate a link for you, the link like this. Okay, and this link you can use in your website or you can share with anyone, uh, and that is your application. For instance, this is the night light data application. When I will click this, okay, yeah, here this is, they are giving me, maybe this application is, or say for instance, this one, Terran. Okay, here, this is the URL. So when I will click this URL, this is the application I develop. If I need to know the slope or of any area, show dam. So it will give me digital elevation model like this, any area. Then I need to know the streams. You will click here on the streams. These streams will be there. And then if you need to know the slope, you will click here. It will give you these slopes. So this is all this link, which is the Earth Engine application, which you can develop like this. I think when you will do some practice, how you can develop your own applications using the Google Earth Engine, then let me explain you again. When you will open the Google Earth Engine, so this code editor, it will come to you after they will authenticate your registration. First, you have to register with Google Earth Engine. So what you will do, you open the Google and then you see the Google Earth Engine, Google Earth Engine. And when you will click Google Earth Engine, maybe, yes, Google Earth Engine. And then you have to click at Get Started here. You will go Get Started. You will see the link to register. Here you have to get registered. Okay, so you can choose unpaid, what project type you want, academic and research, then go to next. And then you can create a new Google Cloud project, or you can continue with registration. Yes, then again, you go organization, then your project ID, then this, and continue with registration. They will authenticate your request via your email, and then they will give you uh, the permission to work with their code here like this. Then you can open this one here. You can open this one and it will show you your project like this here, as it is here. And then using these simple scripts which are available within Google Earth, you can develop your own applications. As I said that these codings are already given there in most of the cases, or if you can do some modification here, like if I want to increase or decrease minimum value, I can do and I can run. The visualization will be changed here. Similarly, you can change the date, you can change the map center here. Okay, so before you do working with code, you can practice with user guide, and these are the guides here. And you can read all about the Google Earth Engine, what are the key features, and then you can look at the video tutorials also. These are the video tutorials. And you can go for quick start also, and they will give you some tips how you can start working with Google Earth Engine. So this is the best way to learn about the Google Earth Engine, because this is a great source of remote sensing analysis or GIS and remote sensing analysis, uh, which not only Google Earth, but you can do working with the you can do working with the Colab. Okay, you can use this also, Google Colab. So when you will work with Google Colab, they give you Python-based libraries which will help you for your data analysis. A variety types of libraries are there where you can integrate your Google Earth Engine. Google Colab will authenticate you. I mean, you can, I mean, import your Google Earth Engine data direct to Google Colab. So this is the way you can move on for geospatial analysis, and it's very a useful platform, Google Earth Engine as well as Google Colab. I hope this is the way you can start working on the remote sensing data using Google Earth, using Google Earth Engine. Uh, you know why I made this Google Earth Engine. I introduced the Google Earth Engine here because this is the cutting edge technology. This is the latest technology, and this technology is getting advanced day by day. So why we should learn something which is outdated? Here direct you can do analysis using Google Earth Engine. You can use this platform for land use and land cover data analysis. Well, as you know, this is the time of this is the time of this virtual learning, and uh, when you will if you want to learn Google Earth Engine, there are many sources. You can look at the Google, you can look at the YouTube videos. They will help you. Uh, I mean, you can learn step by step about Google Earth Engine. Some of you may be interested in this technology, so I will advise you. The Google Earth Engine is the great platform for not only land use, land cover classes, but many geospatial and remote sensing, GIS and remote sensing data analysis. And this will help you for your research publications also. For your research publications, you can collect the data, you can do analysis, and then you can work on the research papers. And if you are working with this technology and using some kind of machine learning, because machine learning is inbuilt there. I mean, in the machine learning, you may be interested for image classification, you may be interested in some kind of data modeling, which is possible within Google Earth Engine. So it will take very less time to prepare a good research paper, and you can publish your research papers in very good journals. Okay, let me show you some of my paper is based on Google Earth Engine. Yes, here this is vegetation trend and dynamics using the Google Earth Engine and R. So this is the way, I mean, I know this is a good source of data analysis and data reporting or developing the research papers. This is a good source, very good source. And then let me move to the climate part here. This is section 3.2, the second part of chapter 3, that is the climate. All we know, the climate is getting space uh, in academics, in the research, in government policies, uh, at very fast rate, more than before. Day by day, the climate issues are more, because the climate is why this climate is important. Because of this climate, it's possible to live at this planet, and the human beings living at any place, that place is specific. That place is known for its climate type. Maybe a person living in savanna type of climate or subtype of savanna. So that type of climate, he or she is adopted to that climate where human being practice agriculture. So their whole life is linked with that climate type. And when that climate is changed, so it will affect their human activity. It will affect their activity, especially the agriculture cycle. The when the agriculture cycle will be disrupted, it will be disaster for whole society. So the climate change will affect the agriculture. It will affect the livelihood, then the migration from rural to urban areas, or the change from agriculture activities to another activities. Then some kind of the problems may rise. So the climate is a very important topic, and it is getting the space in government policies, almost in all aspects. If we say the transport, if we say agriculture, we say industrial development, if we say the international relation and cooperation, international organization, everywhere the climate is there. And if we say the this SDG, sustainable development goals, in all goals, sub goals, everywhere you will see the climate. So the climate is the long-term pattern of temperature, humidity, and precipitation. And all these elements of climate, for instance, temperature, or precipitation, or wind speed, or cloud cover, or visibility, or humidity, or some radiation, remote sensing is helping a lot in this study also. Let me show you the in this part also. The Google Earth Engine is giving us more data. Here is this is data catalog, and we see here this is climate and weather. Surface temperature, we can see, we can look at the surface temperature here. If we click this one, we'll find here. And there are different types of satellite, different programs are there, different uh, model based, I mean developed data is there, which we can use to study the climate. All right. Then before I demonstrate you the data, let me move on with some kind of theoretical understanding. Climate variables. Climate variables, uh, climate variables. In any study, what we need variables. The variables you can divide into two categories, maybe dependent and independent variables. So if one variable is the vegetation change. So vegetation change you can study with the help of NDVI change. So this is one variable, NDVI change. To explain that NDVI change, you need climatic variables. And these variables may be the change in the temperature, change in the precipitation, or change in the, maybe it is not as much important, uh, especially the temperature and precipitation change will explain you the change in the vegetation. So the temperature here, temperature it looks, I mean the temperature is, but it's very complex. What temperature we are talking? Is it a minimum temperature of a day, or maximum temperature of a day, or the range of the temperature in a day, or in a week, or in 10 days, or in a month, or is this a median temperature? What type of temperature is this? Is it the radiative temperature or effective temperature? So there are different types of temperature, and all these types of temperature are useful to study different aspects. Like if we say human health, then of course we have to think of the effective temperature. So effective temperature is the temperature which is feasible, or which is means affecting the human health. For instance, when I say effective temperature, if temperature is 40 degree and wind speed is more, so that 40 degree will not be as much effective. If wind speed is reduced, then that 40 degree will be uncomfortable for human health. So such type of complexities are there. When you will see, when you will read the literature, you will find all such type of things. The temperature affecting the ecosystem, agriculture, and water resources. Then we come to the precipitation patterns. Then again, the precipitation changes from one place to another place, changes in the time series, precipitation change in the minimum, maximum, median, or some standard deviation, variability in the precipitation. All these, the trend in the precipitation, in the I mean the Kendall trend or Sin slope, all these types of analysis will help you to understand the precipitation patterns here. Then the sea level rise, it is linked with the melting of the ice, the extreme weather events, glacier retreat, oceans acidification, biodiversity loss, carbon dioxide level, increase of carbon dioxide level. And then this is the methane and other greenhouse gases, land use changes, energy consumption and emission. When you will read all these points, these are very easy points, easy to understand. Social and economic impacts, international agreement and commitments. All these points are related to the climate. And now the second part is what is uh, the climate perspective of policy and strategy studies. So from the policy point of view, the informed policy formulation, the climate research provides the policymakers with necessary data, insight to formulate the evidence-based policies. Here, the evidence-based policies. This is a very important one when you will write the remote sensing, use of remote sensing. Then this evidence. What is evidence? The satellite images. Satellite images will not lie. Satellite images will give you the information what is being detected by the satellite detector. But for that, you have to be very careful. If you are studying the vegetation cover during June or July using the satellite data, then you have to take care of what type of, the satellite data is there, how much is the cloud cover. So because if the cloud cover is there, then your data will not give you the correct information that how much vegetation cover is there. So for that, there are different ways. I think in the last lecture, someone asked me the question related to how we can minimize the impact or the effect of cloud cover. So there are some techniques for that. We can use how we can use the remote sensing data more accurate. So that accuracy is very important, very, very important. In remote sensing data, there are many more things which can mislead you, if you are so that is uh, the data part. Here we are informed policy formulation, informed, evidence based on remote sensing data. Risk assessment and management, for instance, the assessment of the flood, drought. uh, so all this assessment can be done with the help of remote sensing data. Long-term planning and foresight. How we can do long-term planning by using some predictive modeling. Predictive modeling means this is 2025. Then we can look at that what may be the temperature in 2050, 2080, 2090, or this 2100. Then based on that, what should be the policy um, to combat this climate change impact. Then international diplomacy and agreements are there, which are related to climate change for negotiation, international climate agreements, and assess the impact of climate policies on diplomatic relations. Resource allocation and budgeting, then public perception and engagements, legal regulation and framework, technology and innovation policies, economic implications, and conflict preventions. So the point is, when we say the climate, there is another platform which I feel very important to introduce you, and which is linked to Google Earth Engine, and that is the Climate Earth Engine, climateengine.org here. So this is the link for that. When you will open this link, you will see the platform like this. Here, this is Earth in climate engine. You will see the platform like this. Mm, and then you can look at different climate related variables, which are, yeah, raster analysis. You can see the climate variables. Many climate variables are there. So remember, this is the global part here. Global means the data is available for the for all parts of the world here up to here. But this category belongs to only North America. So when you will open this platform, by default, it go to GridMet, which is part of the North America. You can choose like Terra Climate here. And what Terra Climate is giving you, Terra Climate is giving you temperature, precipitation, related developed variables, wind speed, radiation, and all this data. So if you need to know the precipitation of last um, last year, or we can say last December, January, February. So this is what? This is map. This is the map. So it will come you in the form of map here. So precipitation is very less, only the precipitation here in the coastal areas. But if you will see the June, July, August here, last June, July, August, you will see there is more precipitation. And if you need to download this data, you can download also. You have to select a region of your interest, and then you can download the data. And this data you can download and you can study with your any remote sensing GIS based platform. So these are the values here. If I want to know what is the long-term change in the precipitation, then I can look at the correlation of trend 1981 to 2024. It's better to reduce the time for fast processing. Then look at in last 24 years, this red areas, the precipitation is decreasing here, this part. This part precipitation is decreasing, more decreasing this area. This area precipitation is decreasing. Then so decrease in the precipitation will directly impact the agriculture. It will directly impact the vegetation. And when you see the vegetation here, this area, so for vegetation analysis, you have to go to remote sensing. And here I will take Landsat data, vegetation NDVI indexed. And from, okay, I think I have taken this slab here. So let's say this slab here. So in this area, you will see the vegetation is also decreasing from 91 to 2020 within this period. So all these are the areas where the vegetation is decreasing. So how this data will help you? You can first, before you plan any research related to GIS remote sensing data, related to climate, related to vegetation, you can have a look that which area the vegetation is decreasing. You mark that area, and then you can look at the climate of that area, and then you collect different variables, the precipitation or temperature or land surface temperature. Then you can explain with the help of those variables, extra explanatory or independent variables, that why vegetation is declining here. So this climate data will help us to understand, to do analysis, to do research on any part of the world, uh, on any part of the world. I mean, we can, if we are interested here, any part of the world, we can do the research using the remote sensing data. This is, I mean, without remote sensing data, we cannot, we can, but uh, remote sensing data helps us for faster analysis, evidence-based analysis, and it gives us a wide range of data which is easily available. So here also the Google Earth Engine, what climate data is giving us temperature data, precipitation data, evapotranspiration data, which is very useful for agriculture, production, productivity modeling. Climate reanalysis data is there, wind speed data is there, data is there, solar radiation data is there. All this data is available at Google Earth Engine. So that is historical data. But if you are interested to do some predictive modeling, so for predictive modeling, you can look at uh, one platform that is here. This is cheslaclimate.org. So when you will visit this platform here, you can, first of all, you can read the technical specification. Okay. So all these are the specification given. 1, 2, 3, 4, 5 models. Each model belongs to different places, like the first belongs to US, second belongs to UK, third Germany, fourth France, and fifth Japan. They are giving a different resolution here. So these are the projections. So when you will look at this platform, and when you will go to download the data here, then you will see the time periods 1981 to 2010. This is not the projection. This is the baseline. This is the baseline data here. So when you will click this, you will not look at the models. Here you will not see the models. This is the baseline data. But when you will see this one, you will see these models. And these models, when you will click at any model, so each model has 3 scenarios. The first one is if the development is based on sustainable planning, then this is the model here, SSP scenario 1, where the solar radiation per square meter at the top of the atmosphere will increase 2.6. The second scenario is that if countries are fighting for development, no one is planning for sustainability, then this is the scenario third, where the radiation will be 7.0 watt per square meter above than the pre-industrial level. Here also above than pre-industrial level. And this is the third scenario where the solar radiation will be 8.5 watt per square meter higher than pre-industrial level. So if you are going for considering some, I mean, lower level of development, industrial development, means sustainable development, you can choose this one. And then you can choose the BIOS here. There are around 19 BIOS. Each bio give you like bio 1 is the temperature. Bio 12 I know is the precipitation here. So precipitation when 2014 to, sorry, 2024 to 2040, I think it should be. Yeah, 2011 to 2040. Okay. For next 2041 to 2070, 2071 to 2100. So this is for predictive modeling. Future scenarios. Future, I mean, based on if the temperature is as much now, it will be in 2050, it will be as much, then what will be the NDVI? So this data will help you for predictive mapping, predictive data analysis, like that. So here this is climate data analysis. There are in Google Earth Engine, there are different types of climate. When you can click this, copy this, go to in here, you search this one, you will see the data here. When you will see this data, you can look at this one, see example, and then when you will click see example, you can run it. So this is the fast way, very fast way to look at the data here. What is this? This is the precipitation data, which is only for March, April, May, 1st May to 3rd May. Here, this is the precipitation here. You can click here and you can see that how much precipitation is there. And now if you want to know in July, you can make it 7. You can make it 7 here. And when you will run it, you can see the data. Data will change. So by simple changing the date, you can look at how precipitation is changing time to time. And if you want to know more in detail about this data, you just copy this one here and click this one and go to here, and you can read what data is this, how many bands are there. There is only one band, that is precipitation. And if you want to know more about this data, then you can look at the dataset provider, right click, open, all the details will be there. What data is this? So this is one example. There are um, many types of data available here at Google Earth Engine. We can collect the data and we can do the analysis. Here some examples are given. If you look at this web page using your laptop, and if you are interested to know the precipitation change from 1980 to 2022, then you can click at that place. For instance, you need to know about Gogalada, how precipitation is changing. You click here, Gogalada, and it will give you the precipitation. So this is the easiest way you can use these applications, and you can collect the data. And yeah, here this is the data from 1980 to 2024, I think 2022. And now this is the graph. You can click here to expand this data. This is the trend line. And if you are interested for further analysis, then you can download the CSV also. And this CSV, when you will open, will give you the change in the precipitation. This is pentad data at the difference of 5 days, how precipitation is changing from 81 to 2022. Yeah, this is the data here. And if you you can add the trend line, and you can see the equation here. So there is a very slight increase in in the rainfall. It gives you a slight positive slope here. So this is the way you can look at any place. But remember, this is the data which belongs to, yes, which belongs to this pentad data is this. Similarly, you can look at the mean monthly temperature, how it is changing from 2015 to 2022. So this was all about chapter 3. I hope you got an idea of the land use, land cover, and climate, and how we can collect the data, we can do some analysis, and we can work with it. The objective of this lecture was just to give you an idea of land use, land cover, and climate. And now this is the time. Idea is enough. When you have an idea that you have to do it, then you can search many more things using Google, using YouTube, and you can enhance your knowledge. Okay. So now I think we can discuss something. And now this is the time we can discuss. This is 10 o'clock here. So any question, please?
Hello, sir.
Hi.
No question really, but I just want to inquire if we are going to have access to this chapter 3 also, so that we can read up for more understanding.
Uh, yes, I mean, for final exam or continuous assessment?
Just to continue to read up, to brush up, so that we can be on the same page with you.
Okay. Yeah, you can read the chapter 3, and then in chapter 3, let me show you what you should read. And I mean, I think maybe you need to know the important parts, right? Chapter 3. Yeah. Yeah, I will. Yeah, I mean, uh, it's easy, I think. Yes, Mr. Search, you need to know something. Mr. Search, please.
Yes, Professor. Thank you very much again for this wonderful session. I want to know if you will share with us some suitable links to download the, the appropriate software, and if also we can do some practical session like you just did. Thank you.
Okay. Mm-hmm. So, if you are interested to do some practical using the platforms I explained, then it's good. I welcome your idea. And I mean, what I observe is, uh, yes, so I can give you some task using especially this platform, Earth Engine platform. I can give you some task and I can share with you. Is it fine?
Fine. Yes. Thank you very
Yes,
much.
yes. Thank you very much. Thank you very much. Yes, another question, please. Yeah, Mr. Taiwo, please go ahead if you want to know anything.
No, I'm done with my question. I
Okay.
just I just wanted you to give us material to read so that we can brush up. That you have
Oh,
agreed.
okay. Yeah, these tutorials actually, if you will see this link here, which I have already shared, and again I will share with the class governor, then he can share with you. This is the
Thank
link.
you so much. Yeah, thank you so
Yeah.
much.
Thank you, dear. Thank you. Any another thing which is not clear? And I want to know what about the next class, please. In the next class, I will cover the next 2 chapters. Yeah, for
No,
the I welcome you for the discussion. Anything, any point, if you want to discuss, you welcome.
no, it's not around.
Okay, then I think we can stop here this lecture. Is it? Can we stop this lecture now?
We can, sir.
Okay. So my greetings to all of you.
Yes.
Thank you. Thank you so much for attending this lecture. Then we will
You,
meet
sir.
in the next online class. Okay. Then I will cover rest chapters, chapter 4 and 5. Okay.
Thank you, sir.
Thank you very much. All the best. God bless you to all of you. Thank you very much.
Thank you, sir. Thank you.
Thank you, sir.